So in this problem, we should try to predict the structure of the product based on the mechanism that the reaction goes through. So R2-bromobutane, first we had to make sure that we draw the structure properly. So R is going to be counterclockwise, and if this is 2-bromo, I would have bromine on the upper position here. So butane should have an ethyl and a methyl because this is 1, 2, 3 and 4. So if you want to have an R, it has to be clockwise, and therefore I'm going to have my hydrogen here pointed away from you. So bromine is 1 and ethyl is 2, methyl is 3, and this is clockwise. So R2-bromobutane reacts with sodium methoxide. Sodium methoxide is going to be CH3O minus and Na plus. So the reaction happens by an SN2 mechanism, which means you're going to have an inversion of configuration. Bromine is first priority, and in the product you're going to replace the Br with an O, so that is still going to be the first priority. Therefore you will have an inversion of configuration in an SN2 mechanism. So if I just draw it the way it is right now, and if I simply replace a bromine with the oxygen here, I should be getting an OCH3. And if you look at this, this is going to be a 1, 2 and 3. This is still clockwise, and this is also going to have an R configuration, but that's not what we should be getting. We should be getting the S molecule. Therefore I'm going to simply switch the OCH3 and the hydrogen here, and therefore the right answer for this problem is going to be OCH3, that. So this will be 1, 2 and 3 with the fourth priority group pointed towards you, and therefore this is going to be an S center. So I just use this as an intermediate structure to see if it's an R or an S, and I found out that this is an R. Therefore I switched to groups so I can get S. So this is the final answer that you need to get because the reaction undergoes SN2 pathway. So S3-bromo 3-methyl hexane. So let's draw hexane 6 and 3-bromo. So 1, 2, 3 on the third position. I'm going to draw here 1, 2, 3 on the third position. I have a bromine. So bromine. So this is 1, that is 2, that is 3. So this is counterclockwise, and the hydrogen is pointed away from you. So this is S, and if you draw a structure and if it happens to be an R, make sure you switch the two groups so you get an S. Maybe you can switch the ethyl and the propyl if you get an R to get the S enantiomer drawn correctly. This reacts with methanol, so CH3OH, and this reacts by an SN1 pathway as it is mentioned here. And remember, we discussed in the classroom also, this is a secondary substrate which can react by both an SN1 or an SN2 pathway, but methanol being a poor nucleophile is going to react by an SN1 pathway because it's not going to proactively make a bond unless the carbon gets into an electronic crisis. So the bromine is going to first leave, and then the methanol is going to be reacting as a nucleophile. Anyway, so this reacts by an SN1 pathway. So if this reacts by an SN1 pathway, it obviously is going to give you a carbocation as we discussed in the class, and we are going to get a planar intermediate, and that can undergo a nucleophilic attack from the top or from the bottom. Therefore you're going to get both the R and S enantiomers as a product. Therefore your product structure is going to be OCH3. So that is the product, and you will get a racemic mixture of both the R and the S molecule. So this is going to be 1, 2 and 3. This is S, and this is going to be the R enantiomer. Okay. For problem C, we have 1-bromo 4-methyl cyclohexane. So 1-bromo 4-methyl. and this is a cis molecule. So let's draw it like that, so that we know that this is a cyclohexane ring, and the bromines and the methyls are on the same side of the cyclohexane ring. That reacts with sodium bisulfide, so NaSH. Sodium bisulfide or sodium hydrogen sulfide, they both refer to the same compound. And sodium bisulfide is a strong nucleophile, and that's a secondary substrate. Secondary can go both SN1 and SN2, whereas a strong nucleophile is going to react by an SN2 pathway, so SN2. Therefore, we will expect this reaction to have an inversion of configuration at that carbon. Therefore, the product is going to be predominantly SH, because it reacts by SN2. So this is what the structure is, which is 4-methyl cyclohexane thiol. They have given you the structure, the name of the product, but they didn't give you the stereochemistry, and you should know that the stereochemistry is going to be the trans stereochemistry here, because of the inversion of configuration that the molecule undergoes.